Welcome to the Prompt Engineering Masterclass. I'm your instructor, and today we're moving beyond simple chat interactions to treat prompt engineering as a rigorous software discipline. Most people think of prompting as just asking questions, but for AI enthusiasts and developers, it's about cognition, architecture, and reliability. This 10-minute session will change how you build with LLMs, turning unpredictable outputs into reliable software. When you move from a single chat to a production application, everything changes. Prompt drift, hallucinations, and formatting failures can break your entire pipeline. We need a system to manage this complexity at scale. Our roadmap today is comprehensive. We'll cover LLM foundations, reasoning frameworks, RAG pipelines, programmatic automation, and finally, the critical security and evaluation protocols required for production. I'm your guide for this journey. We've established the course promise to turn your prompts into production pipelines. Let's start with the literal building blocks: LLM cognition and anatomy. Module 1 is about foundations. To prompt effectively, you must understand how LLMs think. It starts with tokenization, how models break strings into numerical values, and the mechanics of context windows. Subword tokenizers, like BPE, process everything from multilingual text to code syntax. Understanding your token limits and the lost-in-the-middle attention phenomenon is critical for maintaining performance when feeding the model large amounts of documentation. Beyond tokens, we look at the anatomy of an API request. This isn't just a text box, it's a structured hierarchy of system instructions, user payloads, and assistant priming. By segregating roles, you establish strict boundaries. You also control stochasticity through decoding parameters like temperature and nucleus sampling. This is where you define the persona and the refusal boundaries for your agent. In our first lab, we build a multi-role customer service persona. This isn't just a bio, it's a set of strict refusal boundaries and formatted response templates designed for consistency. We define the agent's identity, its core task, and most importantly, the negative constraints, what it must not do. This prevents it from being lured into off-topic conversations or leaking internal system instructions. With the foundation set, Module 2 takes us into advanced prompting frameworks. This is where we move from what the model knows to how it reasons through complex problems. We use chain of thought to force step-by-step logic and tree of thoughts to explore multiple reasoning branches simultaneously. These frameworks, combined with self-reflection loops, allow the model to critique and refine its own output before it ever reaches the user. But reasoning is only half the battle. In production, you need structured, type-safe data. That's where structured output enforcement comes into play. By enforcing rigid JSON schemas and using function calling features, you ensure your LLM integrates seamlessly with your downstream software. This eliminates formatting drift and ensures your application can always parse the model's response. Module 3 addresses the knowledge cutoff problem. Retrieval augmented generation, or RAG, is how we ground models in real-time, external data without retraining. The secret to a great RAG system is context engineering. We use advanced chunking strategies and query transformations like HiDE to bridge the vocabulary gap between user questions and your enterprise documentation. Grounding the model also means mitigating hallucinations. We enforce strict citation rules and source attribution to keep the system's knowledge grounded in the provided context. Implementing cross-encoder re-rankers helps filter out irrelevant retrieved chunks before they reach the prompt. This keeps your token counts lean and your signal-to-noise ratio high, ensuring the model only sees the most relevant info. Module 4 moves us into programmatic workflow automation. This is where prompt engineering meets back-end orchestration to create autonomous agentic pipelines. We use React loops and plan and solve strategies to decompose complex goals into dependency-ordered steps. This allows for multi-step LLM pipelines in node-based engines like N8N or full-stack environments like Next.js and Supabase. Managing state and conversation memory across distributed web workers is complex. You need robust error recovery and graceful fallbacks for when the LLM produces malformed or unexpected outputs. Writing clear JSON tool definitions and handling schema validation errors ensures your agents can interact with external services reliably. Always implement model failover routing to keep your application running during downtime. Finally, Module 5 covers security, evaluation, and production operations. If you're building for the enterprise, these steps are non-negotiable for safety and efficiency. You must defend against direct and bottom-up prompt injection. This involves robust input sanitization and using XML tags to encapsulate user input, preventing it from hijacking your system's core instructions. But security is just one part. You also need to evaluate accuracy and tone programmatically. We do this using LLM as a judge frameworks and rigorous regression testing before every deployment. To optimize for cost, use prompt compression and semantic caching for repetitive queries. Model cascading, routing simple tasks to lightweight models, and reserving flagship models for reasoning can save thousands in API costs. To recap, we've moved from basic tokens to complex reasoning frameworks, integrated external data with RAG, orchestrated agentic workflows, and secured them for production. You now have the roadmap for professional prompt engineering home. Thank you for joining this masterclass. Use these principles to build reliable, high-performing AI systems. This is only the beginning of your journey as a lead AI systems architect. In our next lesson, we'll dive deeper into building agentic RAG systems from scratch. I'll see you there.